Alright, hello everyone. In this video we are going to create this third-person character with a third-person camera, which we did from the previous orbit move camera around object tutorial. So yeah, let's dive in. Alright, so I have this sample scene here, which consists of a plane object which is named floor and has a custom material, and also a player object, a capsule object as a player. It has a parent game object which only has a character controller attached, and there's a child object named player mesh, and it actually renders the capsule. And there's also this eyes game object, which is just a cylinder rotated to give this player some more character. Also, we can distinguish the changing directions when we move while we surfing with the camera around the object. So yeah, I'm going to start with creating our scripts, and I'm going to create a folder named scripts, and inside here I'm going to start with our camera. Let's open up this. Alright, in this script we're going to use the exact script from the previous tutorial, which you can find the link in the description below. Alright, now I have my script here, and as you can see, I didn't change anything in the script. It is the same as the one we used previously. So I'm going to save the file and return to Unity, and select my main camera and attach the script to the main camera as a component. So as you see, we need a target to follow, for this camera to follow, and for that we are going to create a empty game object here and name it as camera target. We can move this up a little bit, let's say 0.5, and what we're going to do is we're going to drag and drop this to the target, and that's it for our camera actually. Now we're going to start with our player controller. Let's create a script. Let's open this up. And the first thing is we are going to define our character controller. We are going to reference it in our start method. And then we can implement our movement. We are going to use our update method for our movements. And in here, we are going to write a function called movement. And at the bottom, we are going to define this function. Now, what we're going to do here, first we need to get the inputs, right? And then we are going to create a vector to get our direction. So after that, we are going to create another variable, and we are going to use this variable to store our movement direction, which will be our movement input normalized. And that's it for now. So let's test this functionality before we move on. We are going to pass our movement direction to the move function of the controller. We'll also have a speed variable, and we'll make it serializable in a private field. And let's say player speed. and we're going to multiply this vector with this value. And also, since we're on the update method, let's multiply it with time.delta time. So let's head back to Unity, and we're going to attach this player controller to our player game object. And if we start the game now, so as you see, our player moves. The next thing is we are going to face the player with the movement, the direction of the movement. We can achieve that by checking whether we are moving or not first. So if not, if our vector isn't 0, to make this rotation happen, we are going to use a concept called quaternion, which is a really hard to get around concept. Makes it very simple to interact with rotations. So what we're going to do is we're going to create a quaternion, in other words, a rotation. This will be our desired rotation. And we are going to use the look rotation method from quaternion library. And as you can see, it creates a rotation with the specified forward and upwards directions. So it basically rotates a vector around the upward vector. So the direction we want to rotate is the movement direction, and the upward direction is actually vector dot up. So to apply this rotation to our player, we are going to reach the rotation value, and then let's test it by just assign it to the rotation. Now, as you can see, wherever I move, my player face to that direction. Okay, cool. Now what we're going to do is, improve this a little bit more. Right now it just snaps to the direction immediately, but it would be better to have some kind of slurping, or meaning smooth out that rotation a little bit. And slurp is a function that just do that. It takes a two rotation value, two quaternions, and a time value, which is basically a speed, the rotation speed. So what we're going to do is we're going to smooth out the rotation between the original rotation and the movement direction, right? And then we're going to create a rotation speed value to store our rotation value. So let's say 10F, and we're going to use that here. And since we're dealing with a calculation, we're going to use time.delta time. What did we do? Sorry. So we're going to use the desired rotation, not the movement direction. Yes. Okay, let's save and head back to Unity. All right, now what I'm going to do also is I'm going to make the camera a little bit far so that we can see it better. Okay, now as you can see, there is some smooth functionality between the rotations. Now what I'm going to do, the next thing is, as you can see, when the camera rotates, our player doesn't face, our player movement doesn't affect with the camera rotation. So what we're going to do is, wherever our camera rotates, we want to rotate our player also, if it's moving. So we can achieve that by creating by storing our camera. Let's name that follow camera. No D. And again, we're going to use quaternions. Now, notice that when our camera rotates, its Y value will change. Let's make it not maximize. Okay. Now, as you can see, there is some rotation value changes going on with our camera, right? So we're going to use, I'm talking about this value here. We're going to use that value to rotate our player's forward direction. So what that means, whenever our camera rotates, we're going to apply the same rotation to our player's movement direction. So how we can do that, it's actually very easy once you learn it. We're going to multiply this input vector with the follow camera's Euler angle. And we're going to use the quaternion Euler. We don't need the rotation value in X and Z. What we need is the Y value of the Euler angles from the follow camera. So once we apply that, let's head back to Unity. And if you maximize play, now I'm facing this direction. Okay, nothing happened. All right, yeah, because I didn't attach the camera here. This may not be the best way to reference to the follow camera, by the way, but let's, for the sake of this tutorial, skip that part. So as you can see, wherever I rotate, the player rotates also, and if I stop moving, it doesn't. So cool. Before we finish this video, let's also add the jumping functionality. And for the jumping functionality, we're going to use the official script from the Unity documentation. We're going to use this part and this part. All right, let's apply that. I'm going to create this variables here. I already have a player speed, so I will have this player velocity variable to store our player's velocity, to cache our player's velocity, and we're going to cache the grounded state, and also we're going to have this jump height. I'm using this naming convention to specify that these are the member variables of this class. So I serialize this jump height and gravity value here so that we can able to change them on the inspector. And what I'm going to do is just use this part first, so to check, to cache the isGrounded state of the character controller, and then apply the zeroity velocity if we're on the ground and falling still. So I'm going to change this namings. All right, this is the first part, and then I'm also going to take this part All right, I applied the calculations here, and also to be more synchronized with this piece of code, let's remove this move function to above the rotation calculation, because they're not really related. The movement happens differently with the rotation calculation. So yeah, we have the jumping and we have the rotation with the camera, also forward direction rotation. So let's head back. Okay, let's test the functionality. Okay, I can move around with facing the camera direction. And now let's try jumping. And as you can see, it's very inconsistent. This happens. I encountered this issue when I played around with character controller, and I noticed this skin width and minimum move distance creates this issue. The is grounded check doesn't really work well when these values are assigned, and these are default values. So what I did was to zero out these values, and let's test it. And as you can see, now it works as expected. All right, there we go. Now we combined our two scripts with movements and the camera orbit, and now we have a somewhat functional third-person character controller. Yes, I know it's not perfect, and like the camera can, flow around, just pass from the floor here. It's because it doesn't have collision detection, and I'm not using the official Cinemachine here. And if you want to just start right away with the camera, you can use Cinemachine, but I kind of try to do it manually. Just I wondered how could I do that. Later I'm thinking about adding this camera collision detection, but so far I'm happy with this result. All right, see you on the next videos. Bye.